Alright, let's look at the practice exam 2, problem number 5. So we have this piecewise defined function given, and we want to show that it's a probability density function. Alright, so let's do that. Alright, so first thing we have to check is number 1, it has to be a non-negative function. Alright, so f of x. So this is an easy check, so f of x. Right, so it's defined as 0 when x is less than 0, so we have that. And also when x is greater than or equal to 0, x e to the negative x is always non-negative. So we know that this function is always non-negative. So for all x in between negative infinity to positive infinity, so all real numbers. Right, so we got that. Alright, number 2, we have to show that if you integrate this function over the entire real number, you have to get exactly equal to 1. So we need to compute integral from negative infinity to positive infinity of this function, so f of x dx. Right, and since half of it is actually 0, so you can just go from 0 to infinity. So you have x e to the negative x dx. Right. So since I'm going to have to use the integration by part, I'm going to do the integral right here. So let's just do the indefinite integral first. So you have x e to the negative x dx. Right? Integration by part. So we take the derivative of the first guy, you get 1. And you take the antiderivative of the second guy, you get e to the negative x, divide by negative 1. So it's going to be, I'm going to put the negative sign here. Alright, so multiplying this way, that's going to give us the first term. So that's going to give us negative x e to the negative x. Alright, then minus, right, then you multiply sideways. So you have, but there's a negative sign, so I can turn this into a positive sign. Then you have an integral, and you have e to the negative x dx. Right? Then the first term is already done, so I'll just copy this guy. Negative. Actually, I'm going to, how about this? I'm going to write it this way. Write it as an x over, and I'm going to put e to the x on the bottom. Right? And plus. Right? Antiderivative of this is actually negative, so I'm going to actually turn it into negative. Right? And e to the negative x. So this is, I'm going to write it as a 1 over e to the x. Right? Then plus some constant c. Right? But I'm going to just put the, since there's a common denominator, so you have a negative sign is in common, so put it in front. Then common denominator is e to the x, so you have x plus 1 and plus some constant c. Alright, so in order to evaluate this, so what we have to do is we're going to take the limit as t approaches infinity, and then antiderivative, we found that to be negative x plus 1 over e to the x, and then you're going from 0 to t. Right? And we still have to evaluate the limit. We take care of that later. Then we plug in t. So you have negative t plus 1 over e to the t, minus, there's a negative sign, so it's plus, and plug in 0. So it's going to be 1 over e to the 0. So it's going to be just 1. Right? Then what we can do is we want to take the limit, but you can see that the denominator goes to 0. The numerator also goes to 0. So I'm going to do the L'Hopital's rule here. So taking the L'Hopital's rule, right, I'm going to just take the derivative of the bottom and the top. So you have a negative signs there, but derivative of e to the t is still e to the t. Derivative of t minus t plus 1 is going to be 1. Right? Then you can see that as t approaches infinity, this guy approaches 0. Right? Because the denominator gets larger and larger. Right? So therefore, this is going to be equal to 1. Right? So we got that. So we checked both conditions, right, number 1 and number 2. So we said therefore f is a probability density. If I can spell density, then density function. Alright, so we got that. Alright, then if you want to use this probability density function to find the probability so that the random variable x is between 1 and 5. So let's compute that. So this is going to be equal to, alright, so it's going to be integral is going to go from 1 to 5. Right, so same function, so f of x dx. So this is going to be, or actually maybe why don't I just put the function already here, right? So it's x e to the negative x with respect to x, right? So we already found the antiderivative, so it's a negative x plus 1 over e to the x, and it goes from 1 to 5. So this is going to be equal to negative 6 over e to the 5, negative minus negative, so it's going to be plus, plug in 1, 2 over e. Right? So whatever this value is, this is going to be the probability so that random variable x is between 1 and 5. Alright, that's it. I hope that this was clear.